Good morning. I'm so glad you've joined this online training session. I'm Dr. Derek Fish. I'm director of the UniZulu Science Centre, and I'm delighted to be working with the South African Institute of Physics on this project. You're going to get some fantastic help this morning from some of the best experts in the game. The only problem is that after 2 hours, that help will be over. I want to tell you about some resources the Institute of Physics has made available, which will continue to help you throughout the year, anytime you need them. And the best thing is, they're absolutely free. Let me tell you about the essential skills resources, which I developed in 2020 during COVID. I've been running matric workshops for over 30 years. And during 2020, when we couldn't go to schools, we made videos of all these resources. We called it essential skills because of the idea that facts fade, experiments expire, but skills stick. And every year, the examiner identifies the fact that the main thing lacking in students is not so much knowledge, but the skills. So this was the basis. We identified 4 essential skills for physics for paper 1. That was graphs, free body diagrams, solving equations, multiple choice and ratio questions. I'll show you how these skills cover all 10 of the questions in paper 1. Graphs we further broke down into 4 examples: motion graphs, photoelectric effect, Ohm's law, and internal resistance. And again, this is the comment from the examiner himself. A severe lack of skills is evident: mathematical, conceptual, and integration of topics, free body diagrams, graphs, and equations. So that's what we have tackled here. The section on equations, we expanded to actually cover all of those long questions which involve solving equations. Now, you will see that every single one of the questions is covered here, not necessarily in the same order as a textbook. And these videos and the booklet that goes with it are not a textbook. They do not replace your textbook or your teacher or your notes. They're a revision tool for you to use in preparing for exams. Use them immediately in preparing for June. Use them again in preparing for September trials, and especially for your finals in November. So they're grounded on the curriculum. The relevant theory is covered, but just in brief. Experiments are performed, simulations studied, and exam questions are explored, not just in giving the answers. You don't need that because you have memos, but just explaining strategy and how to answer that. There is a booklet which you can obtain through the Institute of Physics, or otherwise I'll show you how to download it from the website. This is the contents page, and you can see the skills, graphs, free body diagrams, equations, multiple choice. The equation section in red is much longer and is actually expanded to cover all the different types of equations which will come up during that exam. And again, a comment from the examiner: learners still cannot work with scientific equations or formulae. When the theory is covered, it's covered in a very interesting way. For example, you'll talk about Doppler effect today. I use lots of exciting animations to make the concepts clearer. There are also lots of summaries. The strategy for problem solving will be introduced, and a summary of all the graphs of motion that you will come across in matric. And this very useful table for choosing the correct equation of motion when you might not be too sure, particularly for projectile motion, question 3. I cover the syllabus experiments, and for example, this is the internal resistance experiment, and it's covered using fantastic Pasco software and hardware so that you can actually participate in the experiment. Also, lots of useful simulations, particularly from PHET. The photoelectric effect, you'll talk about projectile motion today, and also momentum. And then talk about applications like what would the International Space Station be without its solar panels to generate electricity. When we talk about exams, we make comparisons of at least 3 years of exam questions, looking for common trends and strategies that you can rely on. And let me tell you just how to get hold of these. If you go to the Institute of Physics website and you look up matric material, it'll take you to this page. If you scroll down on that page, you simply ask to fill in your details. This is just so that we can track the use of these resources, but the resources are absolutely free. Press the submit button, and that will take you into this Google Drive where all the materials are available, either to be used online or to download. Here I am on the actual website. You can see all the different files that are there. So the main physics videos are in this folder. If we double click on that, then you can see all 16 of the videos. They're about an hour long each. So this is not something you should use only in November. Start using these fantastic resources now, and they will help you throughout the year. Here are the booklet parts, and you can see their PDFs. It's just a few pages at a time. For example, if we open the one on graphs, it'll show you a PDF with all the relevant pages that you would use and fill in all the exam questions while you are actually watching the video on this point. These, of course, you can watch on screen, or you can decide to print out. We also have exam papers and exam memos, and you can see you don't need to go to the website to look these up. Here are all the physics November exam papers from 2014 all the way through to current. Don't go back before 2014 because that was before the CAPS curriculum. So everything you need is here. There are also all these things for chemistry as well, but we're going to talk about that next Saturday. There's a promo video, a letter explaining things, and all the contents. This is a fantastic resource, and I hope you're going to make the most of this. And you can pause it, fast forward, or rewind as much as you want. If you don't like the sound of my voice, you can just mute me. I wish you all the best for your exams. I won't wish you good luck because that only helps with the multiple choice. But I hope you'll work hard and join us in the physics community in the future. Thanks for watching.
Hello, Itumeleng. How are you?
I'm good, thanks. And
Great. Thank you so much for joining us.
yeah,
Why is the study of science so important?
study of science is important. Let me speak directly to physics. Physics is vast, and there's a lot to learn in physics. There's a lot to learn in a sense that you wouldn't know if you're just sitting out there not doing anything, just reading and doing like reading can make you realize a lot of things, especially with physics. Like myself, I didn't know about this resistive switching memories up until Dr. Dlamini from the Central University of Technology introduced this to me, and then it caught my attention and say, yeah, with all the challenges that comes with it, I just felt like, you know what, I'm up for the challenge. Let's go, let's do it.
Let's do it. All right. So I know that there's a lot of young people who are in high school who are quite skeptical about venturing into careers that have to do with physics specifically. What advice would you give to such a young person?
I will speak to say, not giving up. I was in high school at some time, and they wouldn't believe me when I say I did fail physics and maths. I did get 0 at some point.
Seriously?
I failed grade 10 3 times.
But look at you now.
Now I'm doing PhD. Looking back, it's like it never happened. So yeah, not giving up. Just like have the intention, the dedication to do what you want to do, what you have to do.
And of course, resilience,
Yes.
perseverance,
Yes.
it becomes very important.
Yeah.
Just like yourself, I am a product of SMU, Sefako Mahato Health Sciences University. And I think that being in such an institution where you are exposed to different people from different walks of life, and eventually when you go into the science stream, the physics stream specifically, then you start to see just how these concepts can be applicable in our daily lives. Just really makes you fall deeper and deeper in love with the subject itself. Was that for you as well?
Yeah, it was the same for me. Like I said, somewhere, somehow I did get some zeros there.
Yeah.
But then through dedication and, you know, coming from where I come from, and you are at this side, you've made it to university, somewhere, somehow winning is the only option. They have to win, like it or not. So going back to where you come from, you're just going back to that life of drugs and whatnot. And that's not an option, I guess. So winning was the only option coming this side.
So we are in June right now, and learners are writing their June examinations. So to those who are writing physical sciences, what words of encouragement would you like to share with them?
I think study study before, like you prepare, like you always prepare yourself to writing. You can be a genius whatsoever, but then if you're not studying, preparing for your exams, I don't think somehow you're bound to fail. So preparing for your exams in time and making sure you consult your teachers and whatnot. I think you'll get there eventually.
You know what they say? If you fail to plan, you plan to fail.
Yes.
So study and be prepared. And there's no need for them to be anxious or nervous. I mean, if you could fail pre-10 three times, and now in 2025, you are a PhD student in physics, anything is possible.
And I'm a lecturer, by the way.
And
I'm a part-time lecturer at the physics department.
Listen to that. Listen to that. Thank you so much. Really appreciate it. What's the future looking like?
The future is looking to resistive switching memories. I think, the future just looks bright. I think it's going to do wonders in the future. And I'm just looking forward to that. Also, in the academic area, I think so far so good. Lecturing is going well. And I think, everything about the future just looks bright.
Okay, thank you so much. All right, ladies and gentlemen, my name is Mukosi Mashela. It's a wrap. Thank you so much for indulging us in our conversations. Until the next one, bye.
I'm Jade Morano. Ever since I was younger, I would gaze at the stars with my late grandmother, and from there on, I've had this deeply rooted passion to understand the universe I would look at all the time. It enables me to one day come up with an innovative idea or discover something that could benefit our society and help us grow scientifically. Honestly, every topic involving the stars and astronomy really excites me since it's very much up my alley. I aspire to become a theoretical physicist, so mathematics and physical sciences are fundamental subjects required to pursue my career. Physics can be challenging, but very rewarding, so always test your limitations and surprise yourself. I think that physics is seen as a male-dominated industry, so I would like to flip that perspective and challenge all young women out there to believe in yourself and to really test your limits and see how far you can go in physics to change this perspective. Yeah.
My name is Tamaha Madiha. Having the passion to acquire incredible knowledge, as physics is that one subject that defines life as we know it. Having to do calculations and learning knowledge that's beyond every other subject, like geography or history, physics is just that one excellent subject. Everything with physics in general, especially calculations, makes me want to learn more, as physics can prove life as we know it. I'd like to become an airline pilot, And physics in the aviation sector will help understand aerodynamics, including lift, drag, or airflow, which will help engineers design aircrafts and the technologies. If you love it, it will be excellent for you. Physics, when you learn physics, you step into a different dimension. So do it with passion, do it with love.
Physical science is very bad, then it means the whole science, engineering, and technology is bad. And we also call it the physics of today is the technology of tomorrow. I think those of you who have been listening to the news, you heard that the Nobel Prize for this year was given to the people in physics who invented AI. I think most of you are using AI, Snapchat, and so forth, but that's from physical science. So maybe next time it will be one of you discovering that. And here is a lot of the areas in which physical science people work.
So think about the physics. If they are saying, be in the kitchen, make use of that kitchen to be a genius. Brian has said what a genius is. So I am saying you are all geniuses. You are all going to make it. What I want to tell you is, believe in yourself. You are going to make it. You can do it.
Which topic is difficult? Which do you think is difficult? Yes, work energy and power. You know why you say it's difficult? You say it's difficult because when they ask you and say, use energy principle, you don't know which one to use. And the heating on the surface of this metal, and then if the frequency is of high enough energy, we are going to have what? Electrons ejected there. And you can even see that with these ones here, where are the electrons themselves? Because they are going to be ejected with different velocities, depending on where the electron was. Let's say the electron was somewhere here, it's there. It means that the light will come down to there, impinge on that electron, and then the electron will go that way, assuming that there are no collisions at all. And then if there are collisions, it's going to reduce the kinetic energy of that, and then it will dash off. Okay, and then this one. Right, can you give me the answers now? I think you are now fine. I don't know whether you are all right. Or, but Ara, which one? Oh, sorry. Who said that? You. Tell me, which Ara? The small R, yes.
You say rise, A plus B is C. Initially, I have X of that, which is this one here, and nothing of it. Remember? Now the change comes. This is decreasing. You see that? I will have my minus T and a minus T, and in the meantime, this is starting to increase. Hence, I have my plus T. And then at equilibrium, this is the end of your reaction. Nothing happens anymore. You are now on this block or portion. This is the equilibrium that you have here. Right? Hey, I'm not going to complete this one. You can leave it there for now.
What do we have over here?
Okay, so this is one of our smaller telescopes. It's a 6-inch telescope. It's of Jupiter, and you'll also see the marks on Jupiter's side.
No way, in South Africa.
Yes, sir.
Here, in the motherland. Chai.
We'll ever trust, yeah. No, I don't want to waste what's left. And on we'll go. towards the sun rays. And
Okay. So the future is too bright, as you can see with my upgraded sunglasses. So I'm standing next to the South African Quantum Technology Initiative stall or exhibition stall here at the National Science Week launch. And this is why, ladies and gentlemen, science rocks. And science is for everyone, just like that handsome fella over there. Hello, dude. Hey. Oh, it's me. All right.
echoing around these walls, fighting to create a song. I don't wanna miss a beat.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Good morning, ladies and gentlemen. My name is Suela Kunwana. I am here to share the paper 2 with us, which is coming anytime soon. And we don't have specific topics at the moment. We are all going to look at all the topics that will be written in your exams. Get ready. I'm going to start sharing the slides right now. Good morning. Can somebody let me know if you are able to see the slides?
Yes, we can see them.
Okay. Right, these are the topics that will be covered in your paper 2. That will be organic chemistry, rates of reactions, chemical equilibrium, acids and bases, and electrochemistry. Now, before you start with the organic chemistry, that will be your question 2. In your question 1 is your multiple choice questions, which covers everything around here. I'm not going to touch on all the questions that are in the multiple choice questions, but I'm just going to highlight something that needs to be done. This is what we learners often do when we write a paper. We tend to do the long questions, take our time and waste time and so forth. By the time they say to you, 5 minutes left, you go back to the multiple choice question and you start picking up on any letter that you can find, hoping you will get marks. Yes, if you are lucky enough, you will get your marks. But if you are bad lucked, you'll pick the wrong alphabet and you won't get marks. And let me tell you something that is so nice and interesting about multiple choice questions. You work them out. Most of them, let's say out of 10, 7 of them are 3 marks that are just given to you if you work them out. So I would advise that you start with a multiple choice question, spend about your first 20 minutes on them, answer them, and then you move on. to the next questions. That would be your question 2 and the rest of. I'm not only talking about chemistry here. You do the same again with your paper 1, that will be your physics. I'm not sure if life sciences have got multiple choice in their paper or not, but nonetheless, should you happen to come across a multiple choice question, do not hesitate, go ahead and work on them. Right. Now, organic chemistry, this is the only question that has got 3 separate questions on them. The first one is you naming and writing the formulas and naming the compounds, the organic compounds. This is now covers your homologous series, functional groups, general formula. This is now where you know different types of groups, like your alkane, alkenes, alkynes, alcohols, alcohalogens, carboxylic acid, ketones, all of these. You will learn to know, name, and write their formulas. And apart from this, you also have to know the isomers. You need to define an isomer. Sometimes they will ask you, what is the definition of an organic chemistry? Let's say it happens to pop up. You need to write this one down. It is the compounds of the carbon and hydrogens. These are the hydrogen, carbon, and molecules, I'm sorry, that you find under organic chemistry. Alcohol has got an O, H in it. A ketone has got a C double bond with the O in it. The alkyl halides, they've got the C bonded to the halogens that you find in group 7.
Dr. Suela.
Yes?
Dr. Suela, your slides are not changing. I'm not sure if I'm the only one who cannot see them
No, I
changing.
haven't
Are you still on
changed.
slide 1?
Yes, I'm still on slide 1. I'm still explaining what is happening within this. Yes.
Cool.
Yeah. I'm just giving the background of the chemistry itself, the organic chemistry. Sorry for the interference. Yes. So now, the halogens and the oxygens and the nitrogens, you will find them on the organic chemistry. Remember, we said organic chemistry is only the carbon and the hydrogens. Now, when you come across the oxygens and the halogens, that is now when you know and understand that these are the derived molecules that started from the organic chemistry. And then in your second question, that is now your third question, question 3, this question covers the physical properties of the organic chemistry. The only thing that you need to focus on there are your intermolecular forces, the 3 of them. The London dispersion, which applies to all the molecules. The second one, it will be your dipole. That is the one that you find between the carbon and the oxygens. And lastly, you find the hydrogen bond, the OH. These are the only 3 that you focus on under organic chemistry. But remember, when you're doing the inorganic, you do have all these other forces that applies that you have learned in grade 11 already. And the last question under organic chemistry, that will be the reactions, the chemical reactions, which is what I have picked on so that we can look at this moment. It covers almost question 2 and question 3. The physical properties won't be covered in this section, but at least we know that where we can collect our marks. The first thing that you need to consider here is your periodic table. This is not only for the organic chemistry, it's for the entire paper. When you get a periodic table, you first highlight this. That will be your the metalloids. And you know above the metalloids, that's where you find your non-metals. And this will be your metalloids. And underneath everything else here will be your metals. Keep this in mind. Now, as promised, this is one of the questions. The paper that you are looking at came from November 2024 final exams, which was written by our previous matriculants. One of the questions there it says, which one of the following compounds has hydrogen bond between its molecules? If you find your molecules given to you in this format, you need to expand them so that you can see the different types of groups that fall under organic chemistry. The first one, I chose to write like this. This is your CH3, CH2, your CHO, that is a CHO. You can clearly see what kind of a molecule is this just by looking at it from here. That is my alkyl, an aldehyde. The second one, I can see an ester, the double O's and the C there. The third one, I'm seeing an alcohol. And lastly, I am seeing a ketone. If you look at your structures like this, which one has a hydrogen bond between its molecules? I don't see any. See, I'm looking at the oxygens here. Here, there's a hydrogen bond there. And here there's no hydrogen bond. Do you see how simple and straightforward it is to try and attempt to answer multiple choice questions? The answers are there before us. There's no need for you to go and just pinpoint any letter here because you've got 5 minutes left to solve these problems. Right, are there any questions before we move on to the next question? Okay, I'm going to move on to the next part. This is supposed to be your question 4 in your question paper. It's still the organic chemistry. Here we are dealing with the reactions. The first thing that I ask you to do when you come across a question, you study the scheme. Reaction 1 is the cracking reaction. Sometimes they might not even tell you. They will just say reaction 1. And then they will ask you what type of a reaction is happening there. If they ask this, they have to give you what is happening here. Now they said cracking, it means they won't give you what is you. You have to figure it out yourself. It says here, this compound U, it formed 2 compounds W and T. They're the bottom. I'm looking, this is immediately under reaction 1 there, you can write cracking. And then you look, there's your compound W and T. What is happening with W? The second reaction took place there. Whatever you found there, it formed this alkyl halide. Remember what I showed you in that question 1 from the multiple choice question. When you see compounds that are written in this format, write them in this format so that you can see what you're looking at. At this stage, I can see this is my an alkyl halide or the halo or the halogen onto the organic compound. And to this alkyl halide, reaction 3 took place. They are telling you here this is elimination. Here I can't do anything yet. Once I know what is W, I should be able to know what type of reaction is taking place here. Now from this reaction 3, you move on to the other compound that formed, which is a compound R. I'm not sure what is it, but if I am dealing with elimination, I'm expecting to find a double bond somewhere here because I would have removed the HBr. And they might ask you again, this is elimination reaction. What was removed here? Name the type of the elimination reaction that took place. I can already see here it's a hydrodomination that took place. No, not hydro, dehydro, because we removed the HBr from the compound. Then further on, compound R, the 4th reaction took place, which formed compound S. I still don't know what this compound is at this stage, but at least I am drawing a picture of what is happening here. And then from this compound, the 5th reaction took place, which took us back to what we formed in compound T. So once you have this, you've got your colored pens, you've got your pencils and everything in this question paper, or your highlighters. Note everything that you are seeing here, so that by the time you answer the questions, everything that you need or the information will be on the scheme itself. I brought the scheme back here so that we can try to answer the questions. Define the term cracking. The 2 marks here, I did not put the definition here. I am asking, or I would like our learners to give us the definition of a cracking reaction. Can somebody volunteer to give us the answer? The floor is open for anyone to give us the answer, please.
The learners can also type in the chat. There is the chat line also, so they can type their answers there, or just unmute and say the answer.
I think it is the process whereby longer chain hydrocarbon molecules are broken down into simpler, more useful compounds.
Can you repeat yourself?
The process whereby longer chain molecules are broken down into simpler, more useful molecules or compounds.
Okay. For that, I'm going to give you 1 mark. You know why? Your answer is not complete. It is correct. You need to continue to add and say this happens under high pressure and temperature. Remember, cracking, it happens to the alkanes. And alkanes have got single bonds, and you need more energy to break those bonds, unlike the double bonds. Okay.
Yes.
It is very important for you. You've got the list of the definitions. It's not like they are coming from space. You can go and read them and write them as they are. You can even take them from the memo. Nothing changes with the definitions. They are the same and they are similar. Okay? This is to every one of us. Nay. I'm moving on to 4.2. Is the product in reaction to a primary, secondary, or tertiary haloalkane? And you need to give us an answer. You need to tell us why do you say this is primary, secondary, and tertiary? This is what we are focusing on here. Remember, the primary, the secondary, and the tertiary also applies to the alcohols, the OH groups as well. I know you are used to seeing a primary alcohol, secondary alcohol, and a tertiary alcohol. Can we get an answer from the audience? Thank you for the one who just responded to us. Your participation means a lot to us. Can we have an answer from somebody else? And my colleagues, if you're able to read the charts, can you please interject and give us the answers from the chart? I'm not able to read the responses and also facilitate at the same time. Okay, learners, if I volunteer to give you the answer for the primary, secondary, and tertiary, you need to give me why I said the answer is correct.
Dr. Kunwana?
Yes?
There's a chart that says primary and another chart that says tertiary.
Okay, let's start with the one who said this is tertiary. I was going to say secondary myself, but I stand to be corrected. Why do we say the answer is tertiary? There seems to be someone audible in the background, but we can't hear what you're saying.
Hello.
Hello.
Hi, I'm gonna say that it is a primary haloalkane because the BR it is bonded to the first carbon atom.
Okay, I will accept your answer. Can we assist the one who said this is tertiary and also me because I was also incorrect? We are looking at the bromine here. This bromine is attached to this carbon here. we look at the carbons that are attached to this carbon here. There's only one carbon, hence we have a primary. If we had two carbons like this one here and another one here and the hydrogen here, that would have given us the secondary haloalkane. Or if we had one carbon there, and another carbon, so it is 1, 2, 3 carbons, that will give us the tertiary haloalkane or the alcohol in question. Thank you very much for volunteering to give us the answer. I'm moving on to 4.3 now. It says, write down the structural formula of compound W. There's a difference between the structural formula and the molecular formula. This is the structural formula, and that is the molecular formula. Bear that in mind. If you answer this one here, the 4.3.1, using C4H6, the marks will be out of the window. Likewise, if you say the molecular formula and then you write the structure here, again your 1 mark will go away. So let's make sure that we read our questions thoroughly and we make sure that we answer them according to how they were asked. Follow instructions is very important. The structure of compound W, I have expanded it to you. That one there, 1, 2, 3, 4. And the molecular formula, oh, okay, this one can also be written, this is an expanded version, and that will be the compressed version. Either one of the two is okay. I prefer the compressed one. I know you learners like the expanded one. That's still fine. The molecular formula, there's the molecular formula of U, which will be your C8H18. Are we okay so far, so good? Moving on to 4.4. For the reaction 2 now. Okay, before you move on to 4.4, you already know C8H18. You write it underneath here. You can write it in the formula or the structural or the molecular, it doesn't matter, but as long as you write it here, so that you know what is T and what will be your W. Even the W, you can write it here. But my W is not correct now. It is, sorry. So that's 4 here, and you're supposed to have 4 there again. It's correct, I'm sorry about that. And then from here, I can see this is my alkane. This alkane, in this reaction, I got the HBr. Immediately, you start naming what this reaction is. I can see substitution reaction here. One of my hydrogens was substituted with a Br. So instead of having this here, I have my bromine B. You see how you build up these types of questions. Previously, they gave you the compounds there and there and there, and they say, what is this reaction? Or what are other reaction conditions? There you add your catalyst and so forth. This time around, they didn't give you the name of the compounds, but they gave some information there and there so that you can link your chain backwards or forth. Now, back to reaction 4.4. What is the name or the formula of the inorganic reaction, the reagent that is used here? What do you think was used to replace the hydrogen? To replace this hydrogen with the bromine?
Doctor?
Yes?
There's a question from Chloe. She's saying, please break down the question for me again.
Which question?
Chloe, which question? Oh, maybe she will type. Maybe the question that you were doing now.
Question 4.4.
I believe so, but she will confirm.
Okay. Tebogo, someone is writing on the screen.
Yes, she's saying 4.4.
Okay, we are still busy with the 4.4. We are coming there. It says here, I said, you now know the compound U, which is C8H18. You can write it here. And this U, this reaction took place. It was cracked to give you the compound W, which is this one here, and the compound T, which you can write later, like expand it. From W, sorry about it. There's an error here. I don't know, did I do this? Sorry about that. So from W to this haloalkane, a reaction took place here. What kind of a reaction took place here? I'm telling you, this is substitution. This H, it was substituted by the bromine. The question asked here, what is the name of the formula of the inorganic reagent or the reactant that was added here to this so that you have this haloalkane? Is the question understood now?
Yes.
Okay, can we continue? But before we continue, can we get an answer? I see somebody said HBr here is the answer. Okay, let us try to correct this one. Most of the time, when you have the double bonds, that is when it's easier for you to add HBr. This one is not an addition reaction, it is a substitution. You are substituting the H, you are removing the H and adding the Br to this H. So this is one specific mechanism that is there in your grade 12 or in your CAP syllabus that you must focus on for this year. So instead of you having the HBr, this is what we use. I think you need to go back and revise this section of substitution of alkane molecules. The Br2, because it's bromine, sometimes it will be Cl2. I'm not sure about the I2. Most of the time it's bromine and the chlorine. The chlorine will be the gas and the bromine will be the water. I2 is the solid, so it will take longer to break that bond. So to explain a little bit of brief on this on the Br2, what happens here is when you flash a light, the UV light, to this Br2, it will break the bond. Once that bond is broken, the Br will form a radical. The radical will attack this carbon atom and remove this hydrogen so that the Br stays there. And then you will have your HBr as your byproduct. Remember, there are two Brs here. One Br will sit there and it will bond with this hydrogen here as your product, not one of your reactants. Listen to this. The type of a reaction, choose from substitution, addition, or elimination. I already gave you an answer, Miss. So do you need to answer this one for me again? And then again, write down one reaction condition. I also gave you that reaction condition now when I spoke about the Br2. Let's see if people can recall. I love this question. They just asked something that has never been asked in previous questions, in previous exam papers or in the previous years. They are focusing here on not giving you the compounds or the formulas. They just said S, T, and R. And then they're asking you about this substitution reaction for the alkanes, the single bonds, something that has never been asked in so many years. Can we get an answer for 4.4.2 and 4.4.3, please?
Okay, Chloe is saying substitution.
Yeah. You know what I like about Chloe? Chloe's listening. I kept on saying this is a substitution reaction. That is correct, Chloe. And then what is that one other condition? Let's hear if you listened to this one. What is the condition again?
Notisa is saying catalyst.
Yes, it is a catalyst, but here they don't want you to say catalyst. They want you to be specific, to tell us what kind of a catalyst was used here. Remember, you are used to seeing the platinum and heat and an acid as your catalyst. This time around, they've used a different type of a catalyst.
And Chloe is saying heat.
Heat. Heat is closest because, can I just give an answer to this one? And thank you, Chloe, and Notisa. And Notisa is the first one to join in the group, by the way. Thank you very much for your responses. The other one is the UV light. That's why I said heat is closest. Remember, the UV light is the light from the sun. But we can also use or buy the globes that are UV light instead of taking the sun into the lab to break the bond here for the BR2. So you were closest, but remember to be specific in organic chemistry. When they ask you what type of an acid catalyst is, do not just say a strong acid and so forth. Write it down: sulfuric acid, hydrochloric acid. When they say what kind of a catalyst, a metal catalyst, don't just say metal, just write platinum or palladium and so forth. I think platinum is the easiest to remember. Stick to platinum, you can go wrong. So I'm going to leave this page and move on to the next question. Unless if there are any questions or comments or remarks from the colleagues before I move on. Can we move on?
Yes, I think we can move on, but before we move on, it's important that the learners should go back home and revise what you've done with them so that they now know the answers and how to approach. I hope wherever they are writing down on a notebook what you are giving them, the tips that you are giving them. Because as much as it may seem like a once-off, but it's very beneficial that they keep abreast of what you are doing and they can refer back when you are no longer there. Thank you.
Yeah, definitely. More especially with this one. See, they are bringing something new in these questions. Hence, I'm highlighting them. I was supposed to spend 5 minutes on this, but I realized that if we skip and rush, we will miss out on unknown, not unknown, on the information that was not emphasized in the previous years. And we are not saying we need to ignore what has been asked in the previous years. It's just the added on to what you already know. Okay, I am bringing this again so that we can recall and rephrase so that we can move on. We need the scheme again for the next questions. Uh, 4.5, write down the type of elimination in reaction 3. There they told you what is elimination. And I remember when I first explained this scheme, I did tell you what was eliminated, what was removed from this compound so that you have the color compound R. Can we have an answer to that? Prof. Malauzi? Prof. Malauzi?
I can hear you. Can you hear me?
Yes, I can hear you. Can you please guide the learners for 4.5 and 4.6? Make sure that they give us the answers. I just need to be excused for a few seconds or so. Please, 4.5 and 4.6.
Hello, learners. Can you hear me?
Yes, we can hear you, Prof. You can go ahead.
Okay. Learners, I want you to. I'm losing connection. I want you to take a piece of paper. To take a piece of paper and first try it before we come in. Did you hear me, Lenas? Hello?
Prof, I think they heard you. Some learners are already typing in the answers in the chat box. Can I give you the answers?
Yeah, I think Prof. Vusi is muted.
Prof? Prof? Ah, okay.
You can go ahead, Dr. Swela. I think Prof is having some connection issues.
Okay, all right. Thank you. You know why I was so excited? I'm not sure if somebody knew the answer to 4.5 or if they stole my answer. But nonetheless, the answer is correct. I saw they say dehalodomination. Or you can just say dehalogenation. Dehydrohalogenation, that could be the correct answer for 4.5 as well. You can say dehydrohalogenation or dehydrobromination. Oh gosh. They gave you bromine there. Why would you say dehydrochlorination when there's bromine there? Hence, I am repeating myself. If you read your questions thoroughly, you'll be able to answer the question asked. 4.6 now says, compound R, that one, and T are positional isomers. Remember I said this one I did not expand in the previous question. It will come later. This is compound C. This is what I think came out of the situation there. And that's compound R. You see the positions. One is sitting here on the second carbon, and the double bond is sitting on the first carbon. Now, when you look at these two here, something needs to come to your mind. This is a haloalkane. I eliminate an HBr. I'm expecting to find two products, product A and product B. This is what they will always ask. It appears all the time. In the previous papers, you will see here, they will write major product or minor product. Here, they didn't say it out loud, but here it is. This one could be my major product, and this one could be my minor product. Let me tell you why I'm saying this is major and this is a minor product. This one is major because it's stable. This one is unstable, hence it's a minor product. 1% of this will form, and 99% of it will form from this reaction. There's a rule that we use to answer this question here. Remember the Markovnikov rule and the Zaitsev rule. Zaitsev rule applies for elimination, and then Markovnikov rule applies to addition reactions. Zaitsev rule says, when you remove the HBr, the double bond will have to sit on the carbon that has got less hydrogens. And in this regard, let me take you back to that other reaction.
let's say here, this is where your BR is. Let me put it here. This is where your bromine was sitting. Your double bond, if it sits here, this will give you a minor product. But if your double bond forms here, that should give you a major product. But this is a very bad example for us to illustrate the Zaitsev rule, because your double bond must have your bromine must sit here. This carbon is sitting here. The carbon that is bonded to this carbon has got two hydrogens here. Sorry about that. Sorry, it's me. The carbon that is bonded to this carbon, this one here, it's got two hydrogens. And the next carbon has got three hydrogens. So in this case, I'm expecting my double bond to sit here. That will give me my major product. Are we clear? If your double bond happen to sit on this carbon, that means here, this is in the case where your double bond sat on the carbon that had two hydrogens. That is my major product. And here, your double bond sat on this first carbon here that had three hydrogens here. So this will be my minor product and that will be my major product, and that is your Zaitsev rule. While we are still on this, let's say for instance, I am going to add HCl to this compound here. The hydrogen is expected to sit on this carbon and the chlorine is supposed to sit on this carbon here. That is Markovnikov rule. Markovnikov rule states that the halogen or the OH group will sit on the carbon that has got fewer hydrogens, and the hydrogen will sit on the carbon that has got more hydrogens. This carbon has two hydrogens, the hydrogen will sit here. And this carbon has got one hydrogen, so your chlorine or your OH group or your halogen for that matter will sit on this carbon here. So I've just shown you the two rules, the Markovnikov rule for the addition, and then I've also shown you the Zaitsev rule for the elimination reactions. I hope this clearly highlights and clarifies certain things for you. I am going to move over to 4.6.1, but before we do that, let us wrap up 4.6. Compounds R and T are positional isomers. Here are your positions. Double bond is sitting on the second bond carbon, and the double bond is sitting on the first carbon. Now we can continue with the question. The inorganic reactions shown below are available for the reactions 4 and 5. I've got bromine, sulfuric acid, sodium hydroxide, HBr, and a hydrogen gas. You see, they have stated them here. They didn't say catalyst or acid or heat. They put things as they are. The only time when you can say heat, that is heat. There's no formula for heatness. You can't say fire, or you can't say light. You need to say heat, or you can draw that triangle to say this represents heat. That will be accepted. 4.6.1, it says write down the balance equation for the reaction of this one here. Compound R, this double bond here, something happened here to give you compound S. Let's see what is happening in 4.6.1. Remember, if you write your things like this, sometimes it becomes difficult for you to see how to write your reactions, but if your structures are written in the structural formula format, it's easier for you to see what is happening. Though, even I love this question. Write down the equation for the reaction using the structural formula. They say you must use this, not the molecular formula. This is nice. Instructions followed again. See, this is 5 marks. The reason why I chose not to do question 2 of this paper is because whatever that needed to be done in that question, it's appearing again here. Remember, favorite learners, if you can't master question 2, question 4 becomes a little bit dodgy. But if you are able to do question 2, naming and writing your formulas, when it comes to this question, you will not suffer. I'm going to move on to 4.6.1. There's my structural formula. What happened here? HBr was added to this, and this was formed. Again, Markovnikov rule applies here. I'm adding HBr here. I'm expecting my hydrogen to sit here and my bromine to sit there. That will be my major product. This is where the bromine is sitting there. And another instance where you put your bromine there and your hydrogen there, this is what has formed. So to sum up everything, this becomes your minor product and that will become your major product. So you see now Markovnikov rule shouldn't be difficult for you anymore. And in most cases, this is 5 marks. So they expected you to write both reactions. Let's say this was out of 3 marks. You are expected to write only one equation. You would write this. You will write only this equation here. Your compound, R, plus what was added, the HBr, which was there, and only the major product you will write, not the minor. Because you are wise and you are getting there, you know your story, you should be able to know that Br sits here and the hydrogen sits there. That will be my major product. But again, it is very important for us to read. You don't just read here, you must also look at the mark allocation. It will tell you how many answers or how much more must you give in order to answer your questions. Are there any questions before we move on to 4.6.2? Oh, this is the molecular formula, this one here. If you write it in this way, it's still correct. The only thing that is not correct here is for you to write the molecular formula, the C4H8 plus HBr, and then the answer that you write on the other side. That will not give you 5 marks that you're expecting. Can I move on now? I am now at 4.6.2. The balance equation for reaction 5. You are using the structural formula, again, structural formula, and the correct reagent shown above. You see, there's only 3 marks here. So you're expected to write only one equation, not 2 of them. You can write either one of the 2. I've got this bromine here. I'm going to focus on this one because since this is my major product. To this, we've added the sodium hydroxide, the concentrated. See, they say concentration. Concentration is strong. Strong means it's able to remove. So when you see concentrated, refer to strong, there's more of it. You need power and strength to remove something. That is when you will know that elimination reaction is going to take place here. But once they say dilute, that means substitution will take place. And in most cases, they will say water here. They will add H2O instead of sodium hydroxide. Same applies with the acid. Once they say the acid is concentrated, it simply means elimination is going to take place there. Remember, you need more emphasis to remove the substance. What is it that is expected to be removed here? It's the H. The HBr is going to be removed here so that you form your bond. Let's apply Zaitsev rule again here before we move on to the last question. H, that's Br, and the H, the Br is sitting here. The carbon that is bonded next to this has got 2 hydrogens, and the carbon that is bonded onto the other one has got 3 hydrogens. So I expect my double bond to sit here, not on the first carbon, not like this, but like that. So this becomes my minor product, and this becomes my major product. Listen again to the instruction. The balanced equation for reaction 5 using this and the correct reagents shown above. See, they want the balanced reaction. They don't expect only you to write this organic compound and that other reagent, the arrow, and only this. You need to complete what came out of it. The NABR plus the water is also part of the product that formed from the reaction. So your 3 marks will come from everything that is noted up here. We must just relax ourselves, read the questions, calm down, and then answer questions. The last part, can somebody give us the name of compound T, just for peace sake, please. Compound T, before we move on to the rates of reactions. Any comments or any responses for compound T? Kanye? I read a chart here, it says they can't see 4.6.2 clearly. Is it the visually or understanding the question?
Oh, it was before you display it properly.
It was before?
Before you displayed it properly. So remember, at first, yeah, they couldn't see it because it was not shown like this.
They were ahead of me.
Yes, they were very ahead.
I can see they've got answers. This is nice, it's promising. Yeah. And I
Yes.
also saw the answer here. I saw butene. I saw that.
Yes.
Can I look at this one here and answer it?
Yeah,
Why
you
do
may go.
why do I like the answer butene? It's because you're telling us that the double bond is sitting on the second carbon. That is what is important here. I know someone will say butene or 2-butene. I don't know what is 2. What are you saying? It is very, very important to highlight the carbon at which your double bond or your triple bond is sitting. I saw this answer in the chat. Thank you very much to the one who gave us the chart. I don't know why you're there. Let's ignore you. Ta-da! So there and how we can obtain our 22 marks. You see the 22 marks, my dearly beloved learners. It comes from thinking, recalling, everything that we've highlighted here, you know, it's there. Remember, definitions, do not answer them partially. Give them your most. Don't just answer with bits and pieces. The more you look at your definitions, the more they register. Again, go back to your naming of compounds, writing your formulas, and then understanding your reactions, your addition, elimination, substitution. Today, I brought something that has been ignored for years. The substitution of single bonds, the alkanes. Also go and have a look. There's a mechanism for you, I know, that is there for you to look into. I didn't want to look at the mechanism because I know it's not done in the schools. And to bring something new for you at this stage like that is going to complicate your lives unnecessarily. So I'd rather you do the paper, you become comfortable and confident, and your space is complete. You know that you are saturated. Then you relax, you are able to add more to what you already know. Can I move on now to the question of rates of reactions? Before we move on, is there anything that needs to be highlighted under the organic chemistry? Okay, I'm going to move on if there are no comments or questions. I've got the balanced equation for the reaction here. Okay, yeah, this thing is sitting right on top here. The first thing that you do when you look at the questions, you need to identify what is this that you're looking at. When I look at the question at a glance, it looks like this is chemical equilibrium because of the graph, because most of the graphs are theirs by chemical equilibrium. But it is vitally important for us to understand that this is where I'm dealing with the rates of reactions. Once you have that, your brain knows what you know under rates of reaction. It will recall everything that you know and it will bring them forward. When it comes to answering your questions, you just go and pick. It's like you're picking up the fruits from the tree. You pick and use and put them anywhere you want. Now, we've established that this is rate of reaction. You read the question. The reaction between pure aluminium and excess hydrochloric acid is used to investigate the factors that affect the rate of a reaction in the balance equation below. Sometimes the examiners might be out of line. They will just say reaction between aluminium and not give you this formula. Hence, I gave you the periodic table initially. You need to know that aluminium is Al, hydrochloric acid is HCl. Sometimes it won't give it. They might ask you to write a balance equation giving you only these two here. You're supposed to come with aluminium chloride and hydrogen gas. So this must take you back to your grade 10 chemistry, where you dealt with your different types of chemical reactions. And another thing, they might give you the formula, aluminium, HCl, and so forth, but unbalanced. You need to learn how to balance your equations, or even recall if you don't know or if you know. Most importantly, aluminium chloride is AlCl3. Let's say, for instance, on this side, you've got 4 chlorines here, and here you've got 3. To balance this, you need to change the 2 and the 3s and the 6 and the 2 only. If you write them, there's nothing wrong in cancelling and changing the number, but you can't change the 3 here and put the 4 there. That is not allowed. 5.1.1, another reaction rate that you need to determine. You will notice that I am skipping these ones. They're very and vitally important, but I want you to go and do them yourselves. If I write your solutions here, it means when you're not learning anything. You're taking my definitions and not learning on your own. So I am urging you to go back and make sure that you have your list of definitions ahead of you. Experiment 1. It says 1 mole of HCl solution reacted with 0.5 grams of aluminium to form this aluminium chloride. The graph here is of the hydrogen gas versus time. What is happening here? Initially, I didn't have hydrogen. As the reaction progresses, I slowly started to form hydrogen gas until at a certain point here where the reaction stops. So this clearly tells me that aluminium here is my limiting reagent. I'm telling you because they said so up there. And the HCl is in excess. So once all the aluminium is used up, the reaction stops. The production of hydrogen gas stops. 5.1.2. For the time interval from 0 to 5 minutes, the average reaction rate for the formation of the hydrogen gas is that they gave you the rate this time. Most of the time, they give you some information on other stuff and they say, what is the rate of the reaction during a certain time interval? So here you are supposed to calculate the mass of something. That's where the 6 marks is coming from. Instead of the 2 or 3 marks that you always get, it's now the 6 because you're working backwards. Let's see what is it that they want from us in 5.2. This is your formula for the rate. It's the definition that was asked of you up there. I want the volume. This is given and that is given. I want this. So I rearrange your equation to get that. Unfortunately, my learners, I'm just going to highlight what needs to be done here. The calculations I did out of boredom, but you should be able to do your own calculations here. The question asked here, what is the mass of alumina that was present in the 5 minutes? This is hydrogen, bear in mind, not aluminium information. See the rate of formation of hydrogen gas at this stage. You are finding first your hydrogen, and then you're going to use the mole ratio to get whatever you want. You can get your aluminum chloride, HCl, or your aluminium. In this case, they want aluminium. So once you get your number of moles for your hydrogen, you will use the mole ratio to get your aluminium. I'm not sure how you have or how you were taught to get the moles, but I prefer this method. I can't go wrong with this. It says here, number of moles of aluminum versus the number of moles of hydrogen gas. 2 moles of aluminium reacted with 6 moles of HCl to give you 2 moles of aluminium chloride and 3 moles of hydrogen gas. I'm only focusing on hydrogen and aluminium. I'm saying here the 2 mole of aluminium reacted to form the 3 moles of hydrogen gas. At the end of this reaction, or at the end of 5 minutes, I had 6.74 moles of hydrogen gas. What will be the number of moles of aluminium? This is the X that I don't know. So I'm going to do my cross multiplication. 2 times 6.74 divided by 3 will give you the number of moles of aluminium. Now I can get my mass for aluminium. There's my mass for aluminium. We know the formula, it's there at the back of your question paper. But the question is incomplete. Calculate the mass of aluminium present in the container at this minute. Take the molar mass as that. We've got all of that, eh? No, man, this is another question. Sorry about that. Aha, it's the same question. I'm so sorry. Let's just continue from there. Sorry about that. From the 0.5 grams, only this 0.12 reacted, or it was used. What remained after 5 minutes? Then we say 0.5 minus 0.12. That will give you the exact mass of aluminium that was present in the container after 5 minutes. Remember that part, the initial, used, and excess. You can play around within the 3 days so that you know what is it that you want. Sometimes they give you the excessive and the used. They say what was initially there, or give you the initial. They say find the excess. Of course, you must have 2 unknowns to solve the third one. So this is the route that must be expected of you for these types of questions. Now let us assume that the concentration of HCl stays constant for the duration of this reaction. Use the collision theory to explain the change in the reaction rate from 0 to 5 minutes. Collision theory is something that we learned in grade 11 already. We had concentration, surface area, temperature, was the pressure involved? Something of that sort. These are the things that we bring here. And these are the things that are involved in collision. Let us see what was changed. I think it's the surface area in my space. Because they did not speak about anything that has to do with the change in concentration, like the concentrated or the diluted. And they did not mention anything that had to do with the temperature here. I only saw aluminium, and they said aluminium strip was used here. They didn't say aluminum powder. Sometimes they will say the powder. Then you will know, you must keep in mind that the surface area is coming in place here. So 5.1.3, that one, there you are. This one, the answer is right there, the memo. It's so nice and straight to the point. The larger the surface area, the more contact or impact happens within the particles, and they will move faster, and the collision will be there, and your rate will be faster. So you can use your own weight, but whatever weight that you use, you must stick within these points that are highlighted here. Any comments before we move on to the next question? Question 5.1.4. Kanye? Okay, I'm going to move on. In the next experiment, experiment 1 was repeated, but this time around they used 0.2, they used 2 moles of the HCl. You see now they are changing concentrations. So if you are to be asked the same question of 5.1.3 using the collision theory, you will use the concentration here. Am I still audible? Hello? Hello? Good morning.
Selena's is saying yes.
Okay, I'm not hearing anything so quiet in it. And I also got a message that said my audio is not clear. Okay, thank you. Please let me know if once I say hey. Kanye?
Hello.
It says the recording has stopped.
Yes, I just heard that.
Yeah, can you talk to Tebo and see what is happening there?
Oh, okay.
Right. So in this reaction, they said the concentration of HCl was changed. Now they want you to redraw the same graph to show what happens. Concentration means more impact. It means your rate will be faster. It means your products will be reached before a certain time. So how do we redraw the graph here? Okay, before we even move on, this is another way of answering 5.1.3. The original graph must be drawn to say this was your graph A, and then you draw the required graph next to the other graph so that you see that this is your original and this is after the concentration was changed or after the alteration. Otherwise, if you just write B there, what do we know? What are you saying to us? So you see here, it says here, it was this part, this one here, it was reached here at 5 minutes. So it means this part was reached before 4 minutes. Even if you write your B alone without the A, you need to indicate that this came before 5 minutes to show that the reaction was faster. That is still acceptable. Five 5.2 here says curve X. When you look at this graph, before even reading, you need to consider where is Maxwell-Boltzmann? There it is. You say you did not escape this one. You are not off the hook. You need to come back here. What does Boltzmann talk about? Temperature is involved there and the catalyst. Remember those two. That could be the changes that can apply to your Boltzmann. What is happening there? Curve X is the Maxwell-Boltzmann distribution curve for a reaction under a set of reactions. A change was made to one of the reaction conditions to obtain your Y. You see, from the uphill there, you are down here. So you still have the same number of particles, but they were reached before time. What change was made to obtain Y? I did mention this. It can either be a catalyst or the temperature. and then give the reasons for your answer in 5.2.1. Why do you say whatever you chose is the case? Can we have an answer to that, please? Ooh. Can I tell you what am I commenting on here? I just saw a comment about Markovnikov rule. It says the poor get rich, the poor get poorer, the rich get richer. It's the hydrogens that has got less, the carbon that's got less hydrogen, that will be the poor one. It will be stuck with the bromine. And the carbon that has got more hydrogen, that will be the richer one. It will have more hydrogens to it. That is a nice way of saying, of putting things. You see, when you type, sometimes you make it difficult for others to understand. But if you say it out loud, we are all learning to understand concepts better than how they are presented to us. Kanye?
The temperature was increased.
Hello.
The temperature, aha, thank you, I'm hearing that. Thank you for your comment.
Yes.
Why was it increased? Why would you say that?
The higher the temperature,
Mm-hmm.
particles have more kinetic energy. So large number of particles have energy greater than the activation energy.
Aha, but it's only for 1 mark then. Bear that in mind.
Why over-explained?
It's good to over-explain than to leave less, if you know what I mean. Ne? You are not wrong. Put the answers down. If you keep them to yourself, you go home, the marker won't know that you know this answer. You understand that part?
Yes, ma'am.
Yeah. Oh, yeah. He said temperature. Yeah. Kinetic energy. So this is what they expected you to say in the actual sense. Are you answered?
Yes, ma'am.
Thank you. Not only you, every one of us is answered. And thank you for your answers. And this covers your rate of reaction question. This question, most of the time, you will collect marks from here. As long as you remember your definitions, you are able to answer this Boltzmann using the collision theory and also to interpret your graphs. Remember, sometimes they'll give you the table. The table and the graph are one and the same thing. The information is there. And then they might ask you that long questions to find the mercy or whatsoever. Don't forget what you've learned in grade 10 already, the empirical formulas. They might ask it here. I don't know how they might ask it, but it might pop up. They might even give you a molecular formula and then they say, find the empirical formula of this, or find substance Y or compound X or Y within the molecule itself. So anything is possible with the examiner, so we might not underlook and say, no, this is just the limit. We can't expand beyond our horizons. So are there any questions before we move on to question 6, which will be your chemical equilibrium? I tried my favorite learners to cover everything that's within your syllabus. So we might not even have time to go through everything, but at least we are trying. So before we start with the chemical equilibrium, can I ask a question? How ready are we? So far, so good with organic chemistry and rates of reactions. You can put the answers in the chat so that we can move on. It says here the reaction of carbon monoxide with oxygen gas is investigated. The reaction reaches equilibrium in a closed container at a temperature T according to the balance equation. There's my balance equation, and they told me this reaction is exothermic. Heat is given off. The changes to the conditions of equilibrium are made at different times. T1 to T3 there at the bottom. The graph shows the results obtained. X, Y, and Z are present gases in the reaction A. Before we do anything, I'm looking at the graph. I've got X, Y, and Z. This is the first equilibrium. I can't tell what is what here. This equilibrium was disturbed. I got, this is the disturbance. I might ask you what was changed here. Temperature, pressure, concentration, or was the catalyst added? You will decide, unless if they tell us. And then I see there's a change here. X was decreased here, Y increased, and the Z was decreased. And then the new equilibrium was reached. Again, the disturbance happened here. What changed again? Temperature, concentration, pressure, or the catalyst? From the change, X increased and Z increased. This time around, Y decreased, and then a new equilibrium was reached. Again, this equilibrium was disturbed. Something changed here. From the changes, X decreased, Y decreased, and the Z decreased, and the Y increased. So from this pattern, I can see that my X and the Z fall on the same side of my equation, and the Y belongs to the other side. So now, when I say same side, I'm talking about the left-hand side and the right-hand side. So when I'm looking at the X and the Z, I am assuming this will be my reactants because there's one there, and this is only one, and there's only one there. So my Y will be my product. That is how I am matching them. Remember, because the decrease is coming there, and there's my Y, it's only the one that is increasing. So I can conclude that my X plus Y gave me X plus Z, gave me a Y. There's my X, could be, and that could be my Z, and that is definitely Y. This one can be either. Once you are done with this and you have this information before your eyes, the question comes, same old. Define the term chemical equilibrium or define Le-Chatelier's principle. Again, I am going to take my 2 marks for myself. You can keep for yourself. You answer this one. So far, so good. I'm looking at 6 marks already from organic chemistry, rates of reactions, and now chemical equilibrium. These are the 6 marks from the definitions that you're supposed to know and answer them fully. And again, let's say, for instance, you happen to lose your list of definitions. Go to your memos. The memos have got these definitions. You can go and collect them from there and make a new list. It's not a loss. Sorry. Sorry about that. Now we say use the graph to answer the questions below. At T1, oxygen was added to the container. Write down the letter that represents this oxygen. Was it X, Y, or Z? Remember, Y is excluded, so it's between the X and the Z. What would be your answer there?
X.
X. Okay, we will keep it at that for now, ne?
Okay.
Ah, I owe you 2 rand so that you can go and buy that ice after the session, ne?
Okay.
And then, next question, at T2, the pressure, wait, before we move to 6.1.3, what was changed there? The concentration was changed at T1 because they said that they added oxygen to the container. Are we clear? This is the change that happened here. Now, another change happened here. During this change, they said the pressure was adjusted. It was either increased or decreased. We will answer that question now. Okay. The pressure is adjusted by changing the volume of the container. Was the pressure increased or decreased? This is the part where we look at the, the pressure theory under chemical equilibrium. We say if the pressure is increased, the volume will be decreased. And once the volume is decreased, we will have fewer. Is the reaction written up there? I think I wrote it up there. This black thing is disturbing me. We say here if the volume is increased, the pressure will be decreased. That is the relationship between the pressure and the volume. They are inversely proportional to one another. Now, at T2, the pressure is adjusted by changing the volume of the container. Was the pressure increased or decreased? We look at what is present in the container at T2. What is happening here? X was more and Z was more. So I had 3 of this. Remember, 3 of this on the left-hand side and 2 on the right-hand side. So if the carbon monoxide and the oxygen were present at T2 after the adjustment, it means the volume was increased and the pressure was decreased. Are we clear, guys?
Yes, they are clear. They are also saying increased in the chat box.
No, it's not increased. It's decreased. Let me tell you why we say. They're asking about the pressure here, not the volume. The pressure is adjusted by changing the volume of the container. Was the pressure increased or decreased? Ne? They're not saying anything about the volume, whether it was increased or reduced. What you do, you go back to the graph and you check what happened here. Why? It's only 2 moles, it was less. It's not there. X plus Z together, they give you 3 moles. 3 moles is more than 2 moles. So in order to occupy the 3 moles, you need a bigger volume. Hence, we conclude that here the volume was increased. The volume was big enough to accommodate 2 plus 3 moles. And if the volume was increased, the pressure will decrease. Likewise, if the graph here showed like it was here in this case, the graph showed that Y was increased and the X and Z were decreased. It means the volume was small enough to accommodate only 2 moles, not the 3 moles. So in this case, if pressure was adjusted here, you would say the volume decreased and the pressure was increased in this regard for T1. Now for T2, you now understand. You've got more moles, which is the reactant. And the volume was enlarged to accommodate these more moles. Therefore, the pressure will decrease. Remember the relationship between the pressure and the volume. The higher the pressure, the lower the volume. Or they are inversely proportional to one another. Are we clearly answered? Kanye, I'm relying on you.
They're fine.
Okay, thank you. I'm sitting in an empty room here. It's like I'm talking alone, nobody's hearing me. Hence, I keep on saying, let me know that you are hearing me. Give a reason for your question in 613. I already gave you the reason. Ne? I only forgot to mention the reverse reaction was favored, and I made that deliberately. In the previous questions, they will ask you, is the forward reaction endothermic or exothermic? And then you need to come up with all these things. If you increase the temperature, something changes, and now the reaction becomes endothermic or exothermic. You see, in this question, they try to reverse the mind setting of questions. They are asking the reverse, not the forward or the obvious that has been asked in all these years. But it's one thing that they are asking. They want the same answer. In the other one, is the forward reaction endothermic or exothermic? Your reply is endothermic. Why you say that? The concentration decreased, the reverse reaction is favored. Yeah, but you don't have to think, or the question is impossible. Everything is just the same here. The only difference is that the questioning, it might be somehow funny, not tricky, funny, but once you identify the funny, you'll be able to answer the questions. We are moving on to 615. Write down the name or the formula of the gas that is represented by Z. Like you said, X, up there is oxygen. So obviously Z is carbon monoxide. Carbon monoxide. Unless if it is carbon dioxide, I could say, I don't know. So do you understand when you crack these things, you break them up directly from the information that is given to you. By the time you come to answer these questions, you just go back there and pinpoint your answers and put them down here. This one would require more thinking and this one here, but others are just obvious. They're just sitting there for you to answer your questions. Next question. Give a reason for the answer in the Z. Oxygen and carbon monoxide decreased from the graph here. Wait, where are we now? Wait. There's somewhere when they spoke of the decrease of these concentrations and somewhere they speak of the increase. There's a pattern. There they decreased, here they increased. Hence we know that this is a carbon monoxide if you don't want to look at what you have learned previously. And you know, when it comes to such answers, there is no wrong or right wording of putting whatever logic that you understand from the question. You don't have to go and memorize what is said here. But this one, you can memorize because the answers are the same throughout the years, because they are asking the same question. They are asking if I'm male or female. I am female, I'm telling you right now. You don't need to go and use logic to understand that I'm female. When somebody asks you whether they're asking Chinese or they're asking in their sleep mode or walking mode and so forth, you will still answer the same thing. Mensuela is a female. Hence, I'm saying these types of questions, you need to memorize them. It's just the same as defining chemical equilibrium. But some of these, you can use your own understanding or discretion to answer the same and correct question or the answer. Now, what change in temperature is made at T3? T1, concentration changed. T2, the pressure changed. In T3, now they are saying the temperature changed. So they fooled and messed up with the chemical equilibrium by applying three different factors: temperature, pressure, and the concentration in this regard. Remember, there's another one, the catalyst, which has no effect whatsoever in the chemical equilibrium. So what happened to the temperature? Was it increased or decreased? Let's hear the answer.
It was increased.
Why would you say that? Remember, every time when you say this, when you come across the increase, decrease, give reason. Why do you say that? Or explain. They follow all the time. Okay. Why do we say it was increased? Did you say increase or decrease? I'm sorry about that.
He said increased.
Yes, why do you say it was increased?
sorry, ma'am, network issues. Because the reverse reaction is endothermic, so it takes the heat. That makes sense. Can you hear me? Definitely this Wi-Fi now.
Are we done? Can we verify or look into your answer more deeper and make sure that you have it fully answered? The 3 marks is a lot and it's there, it's given. You are on the right track. You are not far off from what you are saying. Remember here they gave you this, the exothermic reaction, meaning the forward reaction is exothermic according to the first or the initial reaction before all these changes took place. So what happened here? X decreased, Z decreased, and Y increased. So it means during that specific change, I had more of this. You understand that? The equation here is carbon monoxide plus oxygen. It gives you carbon dioxide plus heat. If I increase this heat on this side, it means I'll have more of the reactant. If I decrease the heat, I'll have more of the products. You understand the part? So it means here, your reverse reaction is exothermic because you don't require heat. But I'm sorry, it's endothermic because you require heat for this to form. But according to the statement that is given to us here, your temperature was decreased, hence you have more of the carbon monoxide. But do you understand what I was trying to say to you? You decrease the temperature, you have the increase in the concentration of carbon dioxide. So what happens to the reaction? So it means the forward reaction is favored. That means this forward reaction is exothermic. Remember I said the reverse reaction is endothermic. For you to form, sorry about that, for you to form the carbon monoxide and oxygen, you need to have heat here. So it will be your carbon dioxide plus heat. It will give you the reactant. So that means if you increase the temperature, your reverse reaction will be favored. So do you understand where your answer is not incorrect? It's just that you did not answer what was asked here. If you refer to the graph shows that the carbon dioxide concentration increased, which makes the forward reaction exothermic. Hence, the temperature was decreased here. Are we fine now with the answer? Can we continue to the next question? Before we look into the other stuff, the acids are still waiting on us in the electrochem. The question here or the statement here reads, carbon monoxide gas reacts with water vapor at this temperature. The reaction reaches a chemical equilibrium according to the balanced chemical equation. First thing you do here, you note the phases. If it is aqueous, solid, liquid, or gas. Remember the KC expression. It relies on what is here, the phases. I don't know if you heard of the word rice. You know the tasty rice, or the speckle rice, or basmati rice? This is what I have used here. You can either use this or the long method. The long method, I don't encourage you to use. I'm not saying you shouldn't use. If you understand the long method, there's nothing wrong with you doing it. But remember, there's just too many mole ratios that you need to relate to before you can come to the final answer. As compared to this one, everything is on the table. They said to you, initially you start off with something, and then you move on to the product, or the reaction progresses. As that happens, then you start forming your products, and this will start decreasing. And then eventually you reach the completion of the reaction at equilibrium. Looking at what I am giving here, it says this is the second equilibrium. The first equilibrium was reached, and then it was disturbed. After the disturbance, you will see what is happening here. Initially, we had 0.6 moles of carbon monoxide, 0.6 of water. This is now when the reaction stopped. And then, but before the reaction stopped, you had something present of the carbon monoxide and the hydrogen gas. And they tell you that this is 1 mole of the gas and then 1 mole of the hydrogen gas. During the change, a portion of this decreased, that also decreased by an X amount. And in the meantime, the same portion of carbon dioxide increased or started to form, likewise with the hydrogen gas. At equilibrium, we say 0.6 minus X, same applies there, and there, and there. We are just dropping down. This is pure mathematics. Chemistry is no longer applying here. It will come back later. Note, all of these are given in moles. You see that? Hence, I said mole, and here I've got this in mole per decimeter cube. I converted my moles into the concentration because they gave me some information here. They said if the equilibrium constant for this reaction is 4, Kc requires the concentrations, not the moles, to express it. To convert the moles into the concentration, the formula that you get at the back of your question paper. The volume comes directly from there. There is the concentration, there, and there. Now I have the concentration of all the gases at equilibrium. I can now write my Kc expression. Remember, Kc is the concentration of the product over that of the reactant. The right-hand side over the left-hand side. Sometimes we make that mistake because we are in a rush. You write the reactants here and the products at the bottom. And once you do that, because you know you wrote water and carbon monoxide on top, you will take this and put them there and then your answer will not be correct. I'm not sure how they allocate marks at the marking center if you swap your things around. I really don't know. But we don't want to face that situation. We can just be vigilant, focus, and then we start working on our problems. There's my hydrogen and carbon dioxide. As you see them, I populated here. It's just a matter of substitution. Likewise with the carbon monoxide and the water. We were given that Kc is equals to 4. I substitute that one also to find my unknown here, which will be the X. X was calculated to be this. You see, 0.1 plus x, it comes twice. Again, 0.6 minus x, it comes twice. I'm expecting to see an x squared here. Hence, I'm saying, if you're not able to factorize your quadratic formula, you can use this formula here to find your x. And your x was calculated to be 0.37 moles. After the calculations, I'm sure you can use your calculators, you can do better than me. And this one you can plug into your calculator and get the answer. Now, I want the number of moles of carbon monoxide, which is what the question asked us to do. I've got my x there. Initially, I have the 0.6. I want what happened here. This is what will give me my x. I have the 0.6 there, and this information gave me the 0.37. Hence, the number of moles of the carbon monoxide was calculated to be 0.6 minus 0.37 to give me the 0.23 moles. Remember, initial change in equilibrium. In the rates of reaction in acids and bases, they will ask you about the initially, the used, and the excess. It's one and the same thing here. It's just different wording and logic according to the topic that you're dealing with here. I want to know the mass. The second was calculate the mass. Okay? There's my mass. And that's your final answer. So what is important here in this question is to read what was in the statement and build the table. Once your table is built, you can use your KC expression. You substitute the information from the table into your KC expression and solve the unknown. Remember, if they give you the x, they expect you to calculate the KC expression. If they give you the KC expression, they expect you to calculate either the initially, the change, or the equilibrium. So this brings us to the end of chemical equilibrium. Is there anything that we need to highlight here before we move on to the acids and bases?
Yeah, doctors, a student or a learner that's saying that first time they're seeing this method.
The rice?
Yes, I think so.
So they use the other long method in other ways?
I think so.
Okay, let me go back. Let me just leave this here. What they know, what they have learned, they want the mass of carbon monoxide, right? All of these are given. So you can pick on any one of these, more especially the two here, to determine the limiting reagent. You see that one becomes even longer because of you are given this as an initial. But once you get a limiting reagent, you use the limiting, let's say for instance, water is your limiting reagent. You will use this to determine the used from the carbon monoxide. That will be in number of moles. Once you get those number of moles, that will give you the mass. And once you get the mass, then you can go back and do the same calculations that are happening here. It's not complicated, it's just that it depends on the preferences of individual and how they understand to do this type of problems or questions. And again, it also boils down to the educator, whoever teaches you how to. Sometimes I can put the table and make it more complicated for you. But if you're using the other method, the mole ratio method, it might be easier for me to explain to learners or not. So, but when I looked into this particular question, I saw that the mole ratio method was going to be more complicated and the table was much easier. Hence, I chose the table method to explain or to highlight this type of a question. But thank you very much for expressing your views and opinions and your notes and your understanding of topics as we are going along with them. We are happy that you are learning something. It's not like you're sitting here and not getting anything. So I'm going to move on to the next question, which is your acids and bases. Again, here there are lots of definitions. Define a basic and according to Arenas, or according to Launstead Brewery, or what is an electrolyte, what is hydrolysis, all of these definitions, you need to go and read them up and bring them here. This is another 2 marks. So it's 10 marks already. If you take 10 out of 150, you will see there's a percentage there. That will give you a pass. You will walk out with your 70% instead of the 53% pass. Prof, before we move on to 7.2, can you please hit our learners with the acid and base definition, if you are able to hear us?
Yes, I can hear you. Thanks. I think I've moved to a better location. Now, thank you. Yeah, thank you very much, Dr. Kunana. That was very informative and short. Now, learners, we need to be able to define an acid and a base. And I've always been an advocate that any other question that comes would stem from the definitions. If you check thoroughly everything that she was doing, if you know the definitions, you have half the solution. Now, we need to know what is an acid and what is a base. And there are two popular ways in which you can define an acid and a base according to grade 12. Now, according to Arrhenius, and I've always again tried to give hints. When you say Arrhenius, you must remember that Arrhenius starts with the letter A, so which is going to be aqueous, and aqueous is water. That's the way I've learned that I should not forget. So when you say Arrhenius, you remember aqueous, you remember that aqueous will be water-based. So according to Arrhenius, an acid is any chemical species that, when dissolved in water, forms more, or sometimes they say increase, but Dr. Kunana doesn't want us to say increase. But for today, I'll use that. It increases the concentration of your hydronium ions. So in other words, when you dissolve that chemical species, it now forms the hydronium ions and it increases it from the initial concentration. Arrhenius, aqueous, water. So according to Laurie Bronsted, an acid is any chemical species that donates a proton. Now, the two differences there is that the initial person who described an acid was Arrhenius, and he thought that an acid will only be an acid in water. But then Laurie Bronsted came with the theory that it's not only in water. And I give an example, like you can have carboxylic acid, you can have ascorbic acid, which are solids. It must not definitely be in water. And a base, according to Arrhenius again, will be a chemical species that, when dissolved in water, will increase the hydroxyl ions. And according to Laurie Bronsted, then a base will be the one that accepts. And I always say, bring base, bring the proton, and then acid away proton. In that way, you'll never forget, because you'll see an acid and remember, first letter is A, it's away. Base, first letter is B, is bring. So I've just expanded it so that you must not forget. Please, you do not write this in your work and say acid bring or base bring. No, I'm just doing that so that you must learn to understand, so that you may not confuse, because the problem that we've seen with a lot of learners is that they confuse terms. They know the terms, but they confuse them. I like the way Dr. Kunana said to the other learner, you answered the wrong question. Your answer is right, but it is the wrong question. So please always look at the question, understand the question before you answer. Don't rush to answer the question, because then your knowledge becomes useless. The examiner will not know, or he knows or she knows this, it was just a confusion. Thank you. I hope that sheds light. Thank you.
Thank you, Professor. You know, sometimes definitions are somehow a little bit tedious and consuming. We find it difficult to, to write them or even to keep them in our brains or systems. So it's always nice to come up with devices that will make you remember, so that you're able to answer your questions. Remember, I said some of the wordings, they come from you as an individual. As long as you are answering the correct answer using your own words or method, that is applicable and that will help you go far. Now, if we continue to 7.2, thank you, Prof, for the heads up. Write down the formula of the conjugate acid of the carbonate ion. Again, we need to be very careful of this one. The what an acid of this one, the conjugate base of. But in the conjugate acid of, if they say acid, obviously this one will be your base. I'm going to give you that answer now because of I love you so much. You've been so nice. Hydrochloric acid solution with a concentration of 0.1 is treated with the prepared potassium carbonate of an unknown concentration. Acid, they told you this will be the base. This is the acid base question. Obviously, one is an acid, the other one will be the base. There's your balance equation. Remember, I highlighted this initially, question 5, when we dealt with rates of reactions, that they might give you hydrochloric acid here and not give you the formula. They might give you potassium carbonate and not give you the formula. Or they might even give you the formulas and say, calculate. First thing you do, you need to balance your equation. And if the formulas are not given, only the words, you need to write the formulas. So if this has not yet captured your system of your mind, you need to go back and check. Now, the results of this titration are given. This is the first run, and that will be the second run. And this will be the burette reading. Unfortunately for me, I realized after that I did not get the burette to show you where the reading is taken and so forth, so that we can clearly interpret this table. The question asked there is, what is the value of P? This is the volume of potassium carbonate that was used. Initially, I had this much. So what was in the final burette? So it means here you need to take the final minus the initial. It will give you the used. Or that is what happens. That's how you read your burette. Your burette is something that is like this. There's your final volume up there. That will be your initial, I'm sorry. And your final will be there at the bottom. The used will be somewhere in between here. Like I said, I do apologize for not putting here the burette so that you can clearly see what is happening here. But the table itself is telling us, you have this initially, you titrated, you got that final reading. The one that you use for your calculation is this final minus the initial. That will give you the actual used. I am repeating myself again. In question 5, I said initial, used, and excess. In chemical equilibrium, I said initial, change, and equilibrium. Now I'm coming back here. I'm saying this is what was in the initial burette. This is what was the finally, and this is what was actually used. So to get the use, you say final minus initial will give you the use. You see, they're playing with one thing. in these own questions. And once you get the concept on all of them, you can go wrong. Let us look at the second round now. What is Q? That is your initial Q rate. It's not given. They gave you the final and what was actually used. So for you to know the initial here, you're going to subtract this one from that. That will give you the initial reading of your Q rate. I managed to do this for you. You will find the final answer. I'm sure you're busy snapping what is on the screen with your phones if you don't want to waste time or whatsoever. So I didn't write the final answers because my calculator ran out of battery. So I was not able to do the calculations, but at least you have a clear picture of what is happening here. 7.4, it talks about the methyl orange as an indicator. Explain why this indicator was used. And they want you to refer to the titration of the HCl and potassium carbonate. Before we look into 7.5, let us have a look at what is happening in 7.4. This is the table that is standard for you for CAPS to recall. Types of indicators limited to you for now. These are the pH ranges. The pH for this one is weak acid, this one strong acid, weak base and strong bases. The color changes. I'm not sure how you're going to recall this or memorize this. I have no idea, but this table, it will help you to answer all the questions that have to do with indicators. Methyl red, it's a guide. At least this part is easier for you to answer because of the indications here. The red will be for the acid. A comes before the B. Bear that in mind. So if you put this methyl red in an acid, your solution will be red. During the titration, once you reach the yellow, it means your solution is now basic. There's an immediate color change that says this is the end point, and this is the equivalence point. Now for methyl orange, again, your acid will be reddish and the change will be orange. And once the solution becomes yellow, it means you now have a base. So the change will be somewhere in between the orange. Methyl blue, same applies. Your base will be blue, bromothiamol blue, and your acid will be yellow. And likewise, this one is the one that you know, the colorless and the faint pink. So I'm going to show you the color changes. If you have time in your own space, you can go to internet and just say color changes for indicators. I have indicated there, phenolphthalein indicator. This is before you titrate. At the end point, you get this color. If your color is too pink, it means you have gone beyond. So this will be basic, equilibrium point, and that will be acidic. Clear, pink. There's your clear acid, and there's your pink. That will be your base. This will be your end point. This is for the bromothiamol blue. We've got yellow and blue, acid and base. This will be the end point, the green, blue. I don't know that color. If you're colorblind like me, yeah. But as long as you can see that there are three color changes here. For the methyl orange, your acid will be orange. Your end point will, no, this is red, I'm sorry. And this will be that orangish, and that will be yellow. Same applies with the methyl red. That will be really orange and then yellow for the base. Acid, base. I like to put them in this order so that you are not lost. Acid, base. Acid, and the base. Once you understand these colors, at least colors can be kept in your brains. You can recall color more than this table. Once you understand this color here, you can bring whatever information that you have here and then put it down here. Acid, okay, already this is clear. You have it in the table. Acid, pink, base. and so forth. That way, you can't go wrong in dealing with the, what you call it, with the indicator problems.
Dr. Simana, Dr. Kunana.
Yes.
I think I saw somewhere where there's a table that shows that if it's a strong acid and a weak basic, this is the expected pH. And then if it's a strong acid and a strong base, this is an expected pH. It will help them then identify the indicator. Yes. Yes. So I think that will also help them. Because they may not have the advantage of seeing just the colors, but with that table, I think I saw it in some of their notes. Thank you.
Yeah, hence I said you must take the table or even the colors and put them together and say this color is an acid, it's clear. This is what is expected of you. And then once you are done, then you can go back and look at the pH ranges. That also helps. If you know that your pH scale, where do you find? Let me go back to the table again. I said here, between 5 and 6, this will be your weak acid. Strong acid, weak base, and a strong base. I did highlight that. Why do we say this? I've got a strong acid there. I am likely to choose this methyl orange. There it's chosen. You see that? I've got a weak base. Let's say this acid was in there, you had something else. I was likely to choose bromothymol blue because of the weak base. If I had sodium hydroxide, I would have chosen the phenolphthalein because it's a strong base. Yeah, so these two also, you need to couple them and understand where they lie. I'm not saying you must memorize. Remember, the more you see something, the more it registers in your head. Don't expect to look at this today and write tomorrow. You will find a miracle of life. Then. Okay. So to answer your question here, it says methyl orange. It's a suitable indicator. Why do you choose this? You are referring to the pH and the equivalence point. They're even telling you that you must use this, what pH you must use. They're not telling you about beyond. Remember, they can ask you about pH before the equivalence point. That means your solution will still be more acidic according to this. You will still use methyl orange. And then at the equivalence point, your pH will still less than 7. And beyond the equivalence point, your pH will be greater than 7. So that means the indicator will not be suitable for that particular reaction. So at the end point here, it says that your solution was below 7. You see this answer here? I don't want to lie to you, my learners. I'm not trying to uneducate you. This answer, it doesn't matter how they ask this question. The answer is the same as this one here. So it is in your best interest to know this, not memorize it, know it, and put it down as it is, because that's how you answer it. If your solution was basic, you will use a different indicator and say the pH is more than 7. Do you understand what you're trying to get at here? Okay, I'm moving on now to 7.5. Hydrochloric acid solution. It has got that concentration 0.1 and it is treated with potassium carbonate. This is a 10 question mark. Sometimes it's 8 marks, sometimes it's 9 marks. When you see this many marks, don't get shocked or get a stroke. We're going to break this into bits and pieces. Calculate the concentration of potassium carbonate. Where do you start? You know this, Moss. In that question, yeah, they said they gave you the concentration of HCl and the concentration of this one is unknown. And this It's a stoichiometry, 1:2 mole ratio. And there are volumes. They were given in that table. I didn't go back to the table, but here are the volumes here. They are on the table. Remember, I just chopped to get what I needed for you to answer this. You see already, you've marks. I'm using this formula here without looking at the 5 marks, because the 5 marks will give you a stroke. It's something that you don't want. Another thing, your calculator will give you 0.02622. The instruction in the beginning of the question paper says report to 2 decimal places. And your answer here will be 0.062. Not, once you put this other two, you'll get 4 out of 5. And then, you know, we must be greedy. We need to grab everything we put together so we can answer questions. This one, we can either answer it in this fashion, or you can use the long method, the mole ratio. I remember one of the learners here told us, yeah, she's never seen the rice table. They use this method here to answer the KC equations. You can still use the same here to answer this question instead of using this formula here. This one I don't like because of I've got 1:2 mole ratio. If you are not able to see this clearer, you will miss it here. So rather you follow this method, you will still get the same answer at the end of the day. Are we clear? Is there anything that we need to know and ask before we move on to 7.6? Okay, if there are no comments, 7.6 will follow shortly. Calculate the X in the formula. I mentioned earlier on, you might be asked to address the empirical formula question. There's your X. They want you to find X. I'm just going to put the formula here so that you see what is happening. You've seen this formula. We use this formula to calculate the molecular mass. We want this molecular mass so that we can get this X. Remember, the molecular mass is the mass of the entire molecule. And this entire molecule, it was found to have 174.84 grams per mole. Now, from here, you go to individual. You say this 1.7 is equals to K plus carbon plus oxygen plus hydrogen plus O. Remember, the X is for the entire H2O, not only for the hydrogen here, it's for everything here. There's your 2 times 39, periodic table applies here. That and that and that. So the X, like I said, is for the entire water. And then you can find your X. Your X was found to be 2. This question they like every time. I don't know why. Maybe they think it tricks learners, but you can't be tricked with this thing anymore. It's easy, my learners. It's very easy. Once you grab this 5 marks, I'm telling you, I'm getting 80% from you at the end of the year. Okay, before we move on to the last question in your question paper, by the time you get here, you're so exhausted. But because you know your information and your answers, you are ready, man. By the time you get here, you must be eager. You need to know what you want. And you must answer everything because you have studied and prepared yourselves. Now for this question, initially, I showed you the periodic table for you to utilize. When it comes to electrochem, this is also in your question. The first thing you do, you read your question. You've got table 4A and table 4B. They are the same. It's just that the other one is the opposite of the other, is the mirror reflection of the other one. It says here, increasing strength of oxidizing agent. If you don't know what is oxidizing agent, you need to go and learn it now. For this is reduction. Reduction increases. That means here is your oxidation and there is reduction. You write it down immediately before you even start answering any questions. Same applies here. Increasing strength of reducing agents. Oxidation here, and then reduction here. One will be the opposite of the other.
Let's just say, one say, one of the component thinking. Component thinking.
We are hearing people in the background. Are you part of us, or you are just accidentally talking to us?
I don't think Prof was aware that his mic was on, so I muted him.
Okay. Let me repeat myself while we're still at it. It says the increasing strength of oxidizing reagents. It means here we are dealing with it. Just underneath there you write reduction. And then on this side here you write oxidation. So it means here you will have your oxidation here, and there you will have your reduction. And likewise, here you will have your reduction, and there you will have your oxidation. It will be the opposite. If it's oxidation on this side, the other side will be reduction. Oxidation and reduction. Then you're able to see where this one is more reduced than that one because you said reduction. And if you say this is reduction, that means this is reduction, and the one underneath it will be oxidation, according to the information that will be required of you to provide. Once you understand this table, school is out for you, my learners. You are clear and stay to the point. The things that we need to highlight here, again, it's an electrolyte that you must define. Connectivity or conductivity, I'm sorry. The salt bridge. What is the salt bridge used for? I didn't see it being asked here, but bring it on and put it here in your front page. Should it be required, you're able to answer. Oxidizing agent, reducing agent, a substance that is being reduced, a substance that is being oxidized. All of these things you bring together and put on the table. Once you have that, these are the definitions that are required from you. By the way, listen, use oxidation numbers to explain why you say this reaction is a redox reaction. This question is also popping up. It hasn't been asked in grade 12. You last saw it in grade 11 if you did it already. Some of us didn't do it because of the COVID. But there it is, it's coming. We are going to see now how we utilize this information. Now, 812, write down the formula of the oxidizing agent in this reaction. Why we assign oxidation numbers? We assign them so that we can identify oxidation and reduction. And once we have identified those, we are able to write half-cell reactions for the oxidation and reduction, and then we are able to solve our problems. Now, use for 811, use the oxidation numbers. There are rules and tables in your textbooks that we have used already in your grade 11 to assign oxidation numbers. Unfortunately, we won't have enough time to go through all those rules. If you haven't done them, go back and revise. If you need help, there's a platform here by SAIP where you can go and pose questions. Then we will be there to help and assist you to learn this assigning of oxidation numbers. Oxidation number for magnesium is 0, hydrogen is +1, chlorine is -6 on the left-hand side. On the right-hand side, magnesium became 2+, chlorine remained as -1, and hydrogen became 0. Now, when you look at the number line, numbers are counted from left to right. It's -1, -2, -1, 0, 1, 2, and so forth. Now, from 0 to +2, the numbers are increasing according to the number line that we've learned in somewhere in your grades, lower grades. So once you see an increase in oxidation number, this clearly tells you that magnesium has been oxidized, or magnesium is oxidation. And then hydrogen moved from +1 to 0. The oxidation number here decreased. So that means hydrogen here has been reduced, or hydrogen is reduction. So this is oxidation and that is reduction. So we answered 8111. Write down the formula of the oxidizing agent, reduction. Remember this one here, the opposite of the other. Once you see agent, it means you're talking about reduction here. If it was reduction and you see agent, you know they're talking about oxidation. This is what you have read in the table that we saw in the beginning of this section. So we know, according to our oxidation numbers assigned up here, that H2 was reduced to H plus, from H plus to 0. So this will be our reduction. So therefore HCl is our oxidizing agent. Why is it an oxidizing agent? It is making it possible for magnesium to undergo oxidation. Without it, magnesium cannot undergo oxidation according to this reaction. Furthermore, it is observed that dilute hydrochloric acid does not react with copper. Again, here you go back to that table. You wrote this. Oxidation on top, reduction at the bottom. On the table, you go back and check. Where is where is magnesium? Where is copper? And where is HCl? You will see from the table if the other one is now reduction and the other one is now oxidation. You see, use the table. Copper.
Doc?
Yes?
Before you proceed, let me just give them a hint again. Following the same explanation with base and acid, if it's oxidation, because of the O, it's electrons out. Oxidation, electrons out. Reduction receives electron. If they do that, they'll never forget. Thank you. That's all I wanted to highlight.
Yeah, those tips are helpful. And you know why we are highlighting these? These are the, more especially the oxidizing agent, they confuse a lot. That is why we are bringing them in here so that you are able to define yourself better when you see them. Okay, so 813, explain the observation of the copper being not able to reduce the hydrogen. According to the table, the copper might be sitting either on top or at the bottom. I'm not able to bring the table here so that we can see what is what, but it says here copper is a weaker reducing agent than hydrogen, and it cannot reduce hydrogen. So if you use copper here, that means your hydrogen is now going to be oxidation and your copper will be reduction. But once again, if you understand the table and how to interpret it, 813 and 814 shouldn't be difficult for us to answer. Will dilute nitric acid react with copper? Yes, I said so. Why would you say that? Remember in the previous questions, we said when you come across increase and decrease, immediately after that, you must explain why you said something has decreased and why you say something has increased. I'm asking again here, why do you say nitric acid will be able to react with copper or reduce or oxidize copper? They didn't say reduce here because they want you to answer that question. Explain the answer in terms of the relative strengths of the oxidizing agent. You see, again, you go to the table. You see where your nitric acid is and where your copper is. Then it will tell you exactly what is happening. Can I give you the solution here? So this question 8.1 mainly deals about you interpreting the table more than anything else. And this came from your grade 11. Come to think of it, it's just that here they are just more deeper because they're forcing you to use the table which you did not use in grade 11. Okay. So we have seen how we will exercise 8.1 by using the table. This one, they might ask about the galvanic cell or the voltaic cell. And then, or maybe in the next question, question 9, they will ask you about the electrolytic cell. Either one, they will ask. Expect both. They can't just ask one and leave out the other one, unfortunately. And you can't say, I'm only going to focus on the galvanic cell and leave the electrolytic cell alone, or likewise, or vice versa. You will be killing yourself. Do both. You have time, you've got the ability and the capacity to do it. It's been done before. We know you were taught it. Go ahead. Galvanic cell is represented by the following cell notation. Sometimes they will give you the equation, or they will give you a diagram or something of that sort, and they will require you to write this. Remember, on the outside are the electrodes, and then in between it's your electrolytes or the electrolysis, and your salt bridge is there. Don't forget the function of the salt bridge is very important. They might ask it. Here it's not asked, but it might be asked in your coming exam. Write down the net ionic equation. Net, not full. You see, they gave you the nets here, the ions. So they expect you to write the ions here. This is what I mean when they say ions. They've got ion 3 plus here, and there's ion 2 plus. It is very important for you not to mix them up. I didn't put the platinum there because the platinum is just a catalyst. It's there in the reaction, but it is not participating. It's just speeding up, or it's supporting the reaction to happen or to take place. And don't forget also to write in the phases, more especially in your cell notation when it is asked of you. Now, the next question reads, a stronger reducing agent. You know what? This question is busy and full of reducing and oxidizing agents. They are forcing you, if you haven't understood them, to know and understand them. It's a pattern now. You can't escape this. They started last year, this year again, and next year they will still come. Maybe after 5 years they will change the questioning. But we must not undermine ourselves or decide to sieve or filter our information. Everything has to be brought forward. A stronger reducing agent is now used with the same oxidizing agent under the same conditions. How will this affect the initial EMF of the cell? Will it increase or decrease or remain the same? This question, how do you answer this? Listen to this. A stronger reducing agent. It's now used. Are they talking about the concentration, or they replaced the initial reducing agent to the other? I don't see any concentration being mentioned here, so we're going to ignore the concentration and focus on the replacement. Instead of them using Fe3+, maybe they used zinc 2+. I'm saying maybe, they didn't tell us what was used here. So if it is stronger, what will happen to the EMF? Can we have an answer to that one before we move on to the last question and before we call it the day? Can we have an answer to that one? Can you? It's just 1 mark, but that 1 mark is very important. You can even take a wild guess.
I think they're still thinking, so I'll wait.
Let's give them 1 more minute to think. Not even less than a minute. How, Chloe? Is she still here?
Yes, she's still here.
Chloe?
She's just tired. She's here, but she's tired.
No, she's not tired. She's saturated. Let us unsaturate her. I'm going to break that bond. Yeah, I'm breaking it for you. There's broken. Are you happy now, Chloe? This is just one mark that will not affect or disturb you getting your distinction because you have answered everything. Even if you take a wild guess here, you will still be fine. What I want to highlight to you is that you took long to answer this one question mark. So you need to just answer it. If you don't know it, leave it. If you want to guess, take a wild guess. Like I said, if you're lucky enough for this one only, the multiple choice, you must work them out. This one you must guess to save time. You can't spend 5 minutes to answer a 1 minute question. So this brings us to the end of question 8 and the last one now where you say, I am now getting my 100% or 99% because this one didn't get right. 8.2.2, you didn't get the answer. It's my answer, not yours. So let's see what is happening. This is your last leg. The previous question they asked you about the galvanic cell. Remember the galvanic cell is got two beakers. It's one beaker here and the other one with the salt bridge. The electrolytic cell is only one beaker. Bear that in mind. You might still be asked here to write the cell notation. And the previous one, the flow of electrons. They move from anode to cathode, and here they will move from cathode to anode or vice versa. Bear that in mind. So all of these things, as they come to my mind, I will just pop them out so that you can relate them to each question. When you do your revision, you don't ignore or forget them. They say here a strip of silver is added to 1 mole per decimeter cube solution of lead nitrate at that temperature. There's my lead nitrate. From the look of things, this is my electrolyte. It's in solution. And this is the strip that is inside the solution. What am I doing here? I am electroplating. I am going to deposit some whatever here onto the silver. Or I'm going to dissolve the silver so that it goes from here to something else. This is what is this all about. Now they say you need to consider this reaction. Silver, solid, plus lead nitrate. You get the silver plus, that would be a silver nitrate, I'm presuming, and your lead solid. By means of a calculation, determine whether this reaction is spontaneous or non-spontaneous. What is important is for you to understand spontaneous and non-spontaneous. That is what they want you to know, to answer. They want you to know, they want to know if you understand the difference between the spontaneous and the non-spontaneous. Before we move on, Prof, can you please give us the honor of distinguishing between the spontaneous and the non-spontaneous?
Okay. Spontaneous. They must remember something like a sport. It's automatic. So spontaneous, it happens on its own. Non-spontaneous needs a catalyst. It needs help. I don't want to explain too much because then I would go back to activation energy, which I think they know that spontaneous will have a lower activation energy and non-spontaneous will have a very high activation energy. I hope that explains it.
Loud and clear to me, and I hope it's loud and clear to the learners. Kanye, do we have response to this understanding?
Nothing, ma'am.
Nothing.
Yeah, no, they
Doc,
didn't.
once again.
Prof?
Yes, let me take an advantage and try and explain where they said it's a more reducing agent, what will happen. They must remember that electricity is the flow of electrons. So if you put too much difference between the reducing agent and the oxidizing agent, it will flow more and you will have increased electricity. Thank you.
Prof, the learners are also asking you to repeat the spontaneous and the non-spontaneous. You must speak slower. You are speaking too fast. Please.
Okay. To give you before it needs external injection of lytic and galvanic cell. Galvanic cell occurs on its own. It doesn't need external help. Whereas non-spontaneous, it's electrolytic. Electrolytic needs energy from outside. Galvanic doesn't need energy.
Okay, Prof. Thank you. And before we even try to answer,
Non-spontaneous requires energy to.
Prof, we are losing you there.
Yeah, my network, but okay. Can I type maybe on the on the chat box? Maybe they'll be able to. Can you hear me now?
We can hear you. Yes, please go ahead
Doc?
and type. Yeah, type on the chat box. Okay, before we continue, while Prof is typing on the chat.
Oh, how much?
Hello. Hi, can somebody hear me?
Yes, we can hear you.
Okay, I'll say that it's quiet now, and my network has been acting up.
Hello, people. Is the meeting over or is it still continuing?
Good afternoon, learners. Are we still here? Hello?
Yeah, but they are still here.
Yes,
Some
I'm
of
sorry
them.
about that. We just had a bit of a technical glitch that. Sorry?
Okay, so
Yeah, we just had a bit of a technical glitch. However, we are working on it. We are trying to get Dr. Suela to reconnect onto the meeting, the session. So please bear with us. Prof. Mlaudzu, are you around? Maybe you can pick up in the meantime as we wait for Dr. Suela to reconnect.
Yeah, but they are still here.
Yes,
Some
I'm
of
sorry
them.
about that. We just had a bit of a technical glitch that. Okay. Prof? Okay. Noted. Thank you so much. Okay, in the meantime, let me just take you through some of the exciting programs that we have at SAIP. As you know that we are the voice of physics in South Africa. So this prelims workshops are not the end of our calendar. Well, from the calendar that we have for, helping you guys prepare for the examinations. We are still going to have a few sessions later on in the year to help you prepare for your final examinations. The dates will be announced very soon. So just make sure that you follow us on social media, Facebook and Instagram. We are there. On Facebook, we are South African Institute of Physics. On Instagram, we are South African Institute of Physics, one word. And you can also visit our website, which is www.saip, sorry, yeah, SAIP, let me just quickly double check that, .org.za to find out more information about the work that we do. And secondly, we have previous videos from the June revision and last year's revision as well available on YouTube. So if you go to our YouTube channel, South African Institute of Physics, you'll be able to rewatch this session, last week's session, which really focused on physics, and as well as the June revision session as well. So we have all of this learning material available for you to help you prepare for your physical sciences examination. Then if you also need the Matric Essential workbook, Essential Skills workbook, it is available on our website. If you go to our website and you search for the Essential Skills workbook, you will definitely find it there, right? Those are resources that are available to help you prepare for your final examination, or well, even prelims now. Okay. Right.
Okay, I'm back. I could not even type. Now, let me explain the difference between spontaneous and non-spontaneous. Now, spontaneous occurs on its own under a given set of conditions, whereas non-spontaneous needs external energy to occur. Thank you.
Prof,
Was
you
I
might as
clear?
Yes, Prof, you were clear. You might as well just continue because Dr. Isuela is struggling to connect back to the session.
So you might as well just continue and wrap up the session.
Okay, is there someone who has the slides? Because I don't have the slides. He was the only one who has the slides. I could just give a brief lecture about electrochemistry, but I think they need more of the questions. But let me take advantage and then just give a brief insight, because I know these questions would need them to know the difference between galvanic and electrolytic cell. And then they can ask questions. Maybe she'll come back and join. Learners, let's start. Electrochemistry, it's the chemistry that produces energy from the movement of electrons. Electrochemistry is the study of the reaction that releases electrons and produce energy. Now, the one that loses electrons is called oxidized, and the one that gains electrons is called reduced. Earlier on, I said oxidation, electrons out, and reduction, electrons received. So the oxidation number is the arbitrary number that is allocated to atoms or charged atoms. When it's an elemental atom, it has an oxidation number of 0. But the oxidation number can now be calculated from individual atoms that form a molecule or a compound. Now, the best way, which I think by now you've noticed, what we normally do is to give tips. So when you are given that reducing power table or oxidizing power table, the best for you to remember is that in that table, you'll be given voltages. If the voltage is more negative, because you can only have a redox reaction if there's reduction and oxidation. So normally, you'll be given a reaction, and you must now identify which one is oxidized and which one is reduced. Is the one that is more negative according to the table, and this information you will not get in the textbook. The one that is more negative is oxidized. The one that is more positive. Now, when we talk of more positive, it might be negative. For example, you might have copper as -4 and fluorine as -2. So fluorine will be more positive. They said I talk too fast. Are you guys following me?
Yes, we are, Prof.
Good. Now, when you are now given a redox reaction, the one that is reduced, it's an oxidizing agent, because to be oxidized, you must give off electrons. And if there's no one to receive those electrons from you, then it means you will remain with your electrons. So an oxidizing agent brings about oxidation, and it is itself reduced, and a reducing agent is itself oxidized by giving off electrons, and the whole process is called a redox reaction. That's number one. So a galvanic cell is a spontaneous reaction. It releases electrons on its own. It produces energy. So normally we say a galvanic cell is a chemical reaction that, and an electrolytic cell, it's a chemical reaction that requires electrical energy to push forward the reaction. So we're talking about an automatic reaction or spontaneous reaction. When we talk of an electrolytic cell, it is a chemical reaction that proceeds by absorbing energy. Now, we have A galvanic cell is normally made out of two sets, a half cell reaction. So there's a half cell that gives off electrons, and there's a half cell that receives electrons. And the two are co-joined by a salt bridge. And normally in the exam, they'll ask, what are the functions of the salt bridge? What are the functions of the salt bridge? Number one, the salt bridge completes the circuit. Salt bridge completes the circuit. Number two, it prevents haphazard mixing of the half cell. Number two, it contains inside it ions that balance or equilibrate the charges within the galvanic cell. Now, in a galvanic cell, electrons move from the anode to the cathode. Anode, using my example, anode is away. Anode is where oxidation occurs. Cathode, it catches electrons. It is where reduction occurs. So at cathode, you cut. And when you cut, you reduce. If they remember these simple tips, if they remember these simple tips, then they will definitely get the marks all right. So I will repeat, a salt bridge is simply a connection between the half cells. Electrons move from the anode to the cathode, but with the electrolytic cell, electrons now still move from the cathode to the anode, but from the anode to the cathode. But this time, the anode is positively charged and the cathode is negatively charged in an electrolytic cell. It's positively charged because it is connected to the electrical source, which then connects the anode to the positive charge of the terminal, so that electrons can be pulled from the anode and then to the cathode. Hence, your anode is now negative. Is that clear, learners? Is that clear? I'm just giving you a brief background about electrochemistry now, because I don't have the slides that are with Dr. Kunana. I would just finish the chapter. So one other thing that I've also seen, they will require you to calculate the mass. So you must know which is your electromotive cell. So what you normally do is your
Prof, I think we lost you again.
essence while I still have network. Are you still with me, learners? Must you hear me?
Now we can.
You can hear me? Okay,
Yes.
thank you. Now, learners, is there something specifically you would like us to re-emphasize? There was a question there where they asked, will the potential increase or decrease? Now, remember, I said, definitions will always help you. Electrochemical cell is the flow of electrons. They process it. A vast and the cathode, referring to the potential. And there'll be more electrons rate that translate to a higher energy surge. So that's number two. Number and silver, and they say it's a copper solution and it is blue. And they say if they put silver, the blue color fades. So that means there was a chemical reaction. It means now the copper left the solution and then it got now coated silver. So in the anode, in a galvanic cell, the anode electrode will get thinner because oxidation occurs. And at the cathode, the electrode will get much bigger because the metal is going to be surrounding or deposited on the road. Now, the salt bridge is made out of negative ions and positive ions because the anode takes negative charges will go into the cathode and change the charge. Then it means now you'll have the salt bridge depositing the positive charge so that the cell can continue. The cell stops to operate if it is saturated. Now let's get questions, or if you understand. So I was giving a brief lecture about electrochemistry. What happens? What's important is that you should have two electrodes, anode and cathode. Following my example, anode is hot. Now, anode then means oxidation occurs. And cathode, it means reduction occurs. And I say cut, reduce, oxidation out. Are we?
Prof?
Yeah, that's up.
There's a question here. It says,
Yes, are you back?
Yes, I've been back for a while. I didn't want to interrupt you.
Okay, please continue. My network is also not stable. You may continue. I was just giving them a brief about electrochemistry because we were in electrochemistry. My sister, I'm on the side.
Yeah, the question here, it says, how do I identify if the electrolyte cell is saturated? This is what Chloe is asking us. Prof?
I think we lost Prof again. You might as well just take the question.
Okay.
In and out. What were you saying, my sister?
The question asked here is,
Hello?
how do you identify? It says, how do you identify if the electrolyte cell is saturated? Okay, let me try and attempt to answer this one, Prof. Just hold on, we can't hear you. Chloe, and to everyone, from organic chemistry and your understanding of the word saturation or saturated, it means you can't take in anymore. It doesn't mean that the reaction stops, but there's nothing happening. So once your electrolyte cell or electrolytic cell is saturated, you will see from the voltmeter reading, there won't be any change. It will remain the same. So that means there is no activity happening there. Even if you keep on adding more electrolyte to that solution, nothing will change. That's when you know who you have, like your electrolyte is saturated. And then another thing that we need to also highlight and keep in mind is that the energy conversions. They will ask you about the electrolytic cell, and they say what kind of an energy conversion is required there. Electrolytic is electricity, right? So that one requires electricity. So it means the conversion there, it will be from electricity to chemical. And obviously the other one is the opposite of electrolyte, the galvanic cell. So that one, it will be the conversion of a chemical energy to electrical energy. Are we clear on that note? So there's quite a lot that can be covered or addressed under the electrolytic cells or electrochemistry. We have highlighted the most and the basic ones, and I think what we have shared here with you today will be able to take us further or beyond our means, and this should make you ready for your exams. Vukosi,
Yes, I'm here.
this brings us to the end of the session from my side. I am open to questions or any suggestions from learners. They can say anything that they need to say so that we can help them to even to prepare themselves further or beyond.
Okay, learners, the floor is yours. If you do have any questions, you can either unmute your mic or you can type it on the chat box. And either Dr. Suela or Prof. Mulawudzi will answer your question. So I'm going to give you about 30 seconds. After 30 seconds, then I will close the session if there aren't any questions.
Vukosi and
Yes,
Doc.
please.
We are
Yes,
here,
Prof.
Professor. We can hear you.
Sorry.
Okay. It seems as though we don't have any questions. Thank you guys so much for tuning in. We really appreciate it. And we know and believe and hope that through the work that was covered today, you will be ready for your prelims. Take into consideration everything that Dr. Suela shared with you, Prof. Mulawudzi shared with you. If you do want to rewatch this session, it will be available on our YouTube page, which is South African Institute of Physics. Please do follow us on Instagram. We are South African Institute of Physics. And then Facebook, we are South African Institute of Physics as well. So that you can keep on, well, stay up to date with the different programs that we have. All the best for your prelims. We will have another sessions for the NSC final examinations in September for physics, and then chemistry. It's going to be the first week of October. But for now, you got this. All the best. And yes, we can't wait to welcome you into the field of physics and chemistry next year. Thank you so much, Prof. Mulawudzi, and thank you so much, Dr. Suela, for such a powerful session. We really appreciate you. From us at SAIP, have a wonderful day. Bye-bye.
Thank you, Masale. Thank you, Doc. Thank you
Thank
very
you,
much.
everyone. The day was lovely.
Thank you, Doc and Prof, and take care.
Bye.
And Dr. Wolf, how are you?
I'm good. How are you, sir?
My cell phone still works.
I was checking mine if it
Have a
still
lovely
works,
day.
but
This is live. Have a lovely day.